Good morning, students. So today we will start a new chapter, that is sound. So what is sound? The definition of sound is the sound is a form of energy. Obviously sound is a energy. So the definition is the sound is a form of energy which creates sensation of hearing in our ears. Or in other words, you can say that sound helps us to hear something. Okay. Now how sound produced? The sound produced when a object or body starts vibrating. For example, I am speaking, and that's why you can hear and you can hear my voice. Why? Because I have a vocal cord, okay, inside my throat. So when this vocal cord vibrates, it produces sound. For example, there are another examples. Suppose you have a rubber band, okay, and you have you have keep one end of this rubber band inside your mouth, okay, and you have stretched this rubber band, and the other end you have keeping in your hand. Now in this condition, in this situation, if you pluck this rubber band, one pluck means if you stretch this rubber band with your another hand and then release, then what will happen, this rubber will start vibrating. Now when this rubber will vibrate means it will go up and down, okay, or it will do to and from motion, it is called vibrating. So when this rubber will vibrate, you will hear a very soft sound. So this shows us that when a body or object vibrates, it produces sound. Now sound is a mechanical wave. Mechanical wave means those waves which needs a medium to propagate. So sound is also mechanical wave. So that means sound needs a medium to propagate. Sound cannot travel in vacuum because in vacuum there is no medium. Okay. And the speed of sound is maximum in solid, and speed of sound is minimum in air medium, and it cannot travel in vacuum. So the speed of sound in iron, it is nearly 5000 meter per second, okay, and water, it is the speed of sound is 1500 meter per second, and in air its speed is nearly 330 meter per second. Now now propagation, next topic is propagation of sound wave in air. Now how sound wave propagates? For example, so I'll give you a very basic example. Suppose I am speaking here, okay, so suppose this is me, okay, so I am speaking. So I am speaking means my I have actually vocal cord inside my throat. So when it vibrates, it produces sound, okay, so I am producing sound. And suppose someone is here, so it is the ear. Yeah. So and between so what is between me and suppose this is my friend. So what is between which medium is lies between me and my friend? So that means so there is actually air medium which lies between me and my friend. Okay, so when I am speaking, so I am producing some okay, I am producing some sound, and suppose there are only five particles, air particles, or suppose there are six air particles in this medium. So when sound wave will propagate, that means so when the sound will propagate, it will first strike the first particle, first air molecule. The first air molecule will strike the second air molecule. Second air molecule hit the third molecule, and so on. Okay. So in this way, sound wave propagates. Okay. And when this first particle hit the second particle, it will again come back to its original position. This property is called elasticity property. Elasticity, I hope you heard the word the elasticity before. Elasticity, rubber is called elastic. Why? Because if you stretch the rubber and then release it, rubber come back to its original position. So this is the property of elasticity. So this air particles, they will hit the another air particle, and then again it will come back to its original position. This coming back to its original position, this property is called the elasticity property. So this first particle will hit the second particle, third particle, and so on. Okay, so in this way sound wave propagates. So here the detailed explanation of this propagation of sound wave is given. So suppose you have a metal strip, okay, and it is connected. So this box like this, suppose a rubber pad, this box. Now suppose you strike this metal strip. So if you strike this metal strip, what will happen? This metal strip, it will come forward and backward. It will go forward and then it will come backward. Okay, so then that means it will vibrate just like this rubber. So when and suppose there are some air molecules. Okay, so assume that this first air molecules is second, third, fourth, fifth, sixth, seventh, eighth, nine, 10, and so on. Now when this metal strip, it will go forward from position A to position B. So it will push the air molecules. So it will push the first air molecule, and then the first air molecule, it will push the second molecule, and second molecule will push the third molecule, and so on. So that means the air molecules, so this rubber strip, it will push the air molecules, then means the air molecules nearer this rubber strip, sorry, metal strip, they will compress. So this region is called compression region. This region is called compression region. So that means the air molecules will compress. So you can see that air molecule, they have compressed here. Now 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 this rubber strip, okay, so it will go first, it will, when you strike this rubber strip in forward direction, it will go, it will stretch in the forward direction, and again it will come back to its original position from position B to position A. So in this situation, you can see this compression region, it will go forward direction, but the air molecules nearer this rubber strip, they will come back to its original position, okay, due to the elasticity property. Now when this rubber strip, it will go in backward direction from position to from position A to position C, what will happen? This rubber strip will pull the air molecules. So in the first case, it push the air molecules, and here in the second case, when it will go in backward direction, it will pull the air molecules. So it will pull the air molecules means the air molecules nearer this metal strip, they will, the distance between air molecules will increase. So you can see the air molecules, they are very far from each other. Okay, so this region is called rarefaction. RAFRACTION. This region is called rarefaction. Okay, so it will create a rarefaction. So that means the air molecules, they will be apart from each other. Okay, then again this rubber strip, it will come back to its original position from position C to position B. So when it will come back to its original position, the air molecules nearer this metal strip, it will, they will come back to its original position. But during this so during this one complete vibration, you can see this metal strip already creates a compression region. Region means when the air molecules are very close to each other, and it also creates a rarefaction region. That means when the air molecules, they are apart from each other. So in this way sound wave propagates. So it creates a compression and rarefaction region. Okay, so again this rubber strip, it will again come back to its original position, and then this whole process, it will repeat. So in this way sound wave propagates in the form of compression and rarefactions. Now there are some terms which are related to a wave. The first term is amplitude. Amplitude is the maximum. What is the amplitude? The amplitude is the maximum displacement of a particle of medium on either side of its mean position. It is called amplitude of the wave. The maximum displacement of the particle of a medium on either side of its mean position is called the amplitude of the wave. Now remember, this definition of amplitude is called the, this actually not for sound wave. This is the definition for this is the definition for transverse wave, but sound is a longitudinal wave. So for sound wave, you will write that the distance between two consecutive compressions or air frictions is called amplitude. Okay. So for sound wave, we can write the distance between two consecutive compressions or air frictions is called amplitude. So here this so here one compression creates. So when this metal sheet will go forward direction, again it will create a compression region. So this distance between two compressions is called amplitude of sound wave. So but for but this definition given in the book is the maximum displacement of the particle of the of medium on the either side of its mean position is called amplitude. So what this statement means? So look, if you drop something in the water, it creates ripples, and these ripples they are actually waves, and these ripples they are actually look like this one. So what is amplitude here? Amplitude is the maximum displacement from the mean position. So this wave, so this much distance, this orange length, so you can see the maximum displacement from the mean position means this mean position means this line, this horizontal line. This horizontal line is just in the, it lies in the middle of this wave. So from this mean position, so this is actually your mean position. So from this mean position, the maximum distance, so this much distance is your amplitude. The second thing is time period. Time period is the time taken by a particle of medium to complete its one vibration. So suppose this is your wave. So in 1 second, how many this kind of wave created by that source is called the time. No, sorry. Time period means suppose this is this is the wave. Okay. So in 1 second, how many? Sorry, this wave, one wave, this wave creates in how many seconds? It's called the time period. Yeah. What is frequency? The number of complete vibrations. So the number of complete vibrations produced by the particle in 1 second is called the frequency. Suppose if this is your wave, so in 1 second, how many this kind of waves created by that source is called your frequency. Okay, and time period, for time period is the time required to create only one wave, only one this kind of wave is called the time period. But frequency is in 1 second how many waves are created is called the frequency. And the unit of amplitude is so what is amplitude? Amplitude is the maximum displacement from the mean position. So it is measured in, so it is actually a displacement, and unit of displacement is a meter. What is the time period? Time period is the time taken by the particle. So time taken, so its unit is second, and the frequency, the unit of frequency is hertz. Now there is a relationship between time period and frequency. The relationship between time period and frequency is equals to 1 by time period, or time period is also equals to 1 by frequency. So that means frequency and time period they are inversely proportional to each other. Okay. So this time period and frequency. What is so? And the last definition is wavelength. So what is wavelength? That distance traveled by the wave in one time period of vibration of particle of medium is called the wavelength. The distance traveled by the wave in the one time period. So in a one time period time, so this wave, how many distance it covers is called its wavelength. Yeah. In longitudinal wave, the distance, so obviously, so this wavelength, the unit of wavelength is meter, because it is the measure of distance. In longitudinal wave, the distance between two consecutive compressions or two consecutive air frictions is equals to 1 wavelength.